The immensity of the universe confronts us with a fundamental question, echoing through the centuries. Are we alone? This question, charged with mystery and fascination, drives the relentless search for answers, a daring scientific journey that takes us to the frontiers of knowledge. In this video, we will embark on an exploration of SETI, the search for extraterrestrial intelligence, an endeavor that challenges our perceptions and expands our understanding of the cosmos. Using giant radio telescopes, analyzing complex data, and searching for subtle signals, scientists worldwide dedicate themselves to deciphering the universe's secrets and answering the question that has intrigued humanity since the dawn of time. Prepare for a fascinating journey that will explore the different methods used in the search for intelligent life beyond Earth, revealing the challenges, hopes, and implications of a discovery that would forever change our view of our place in the universe. SETI, or the search for extraterrestrial intelligence, isn't just a search for alien life, it's a search for alien technology. The central premise is that a sufficiently advanced civilization would leave detectable technological traces, even across interstellar distances. This approach, unlike the search for simple biological signs, focuses on evidence of advanced technology such as radio transmissions, lasers, or even remotely detectable megastructures. The history of SETI dates back to the 1960s with the pioneering work of Frank Drake and his project OSMA, which used a radio telescope to listen for radio signals from two nearby stars. While it didn't find evidence of extraterrestrial life, Project OSMA laid the groundwork for decades of subsequent research. Since then, SETI has evolved significantly, incorporating new technologies and methodologies, such as the use of supercomputers to analyze vast amounts of data and public participation in distributed computing projects like SETI Home. The search involves interdisciplinary collaboration, combining astronomy, physics, biology, computer science, and other fields of knowledge, reflecting the complexity of the challenge and the breadth of the quest for answers to one of science's most fundamental questions. SETI is not just a search for signals, it's a search for meaning, an exploration of our own existence and our place in the vast universe. Radio astronomy stands out as one of the most powerful tools in the search for extraterrestrial technology. Unlike visible light, radio waves can penetrate clouds of interstellar dust and gas, allowing us to listen to the universe at unimaginable distances. Giant radio telescopes, such as the Very Large Array VLA and the now inactive but iconic Arecibo radio telescope, are essential for this search. These instruments are designed to detect extremely weak radio signals that could indicate the presence of extraterrestrial technology. The technique involves scanning specific frequency bands of the radio spectrum, searching for patterns or anomalies that cannot be attributed to natural sources. The search is meticulous and requires the processing of vast amounts of data, often involving sophisticated algorithms to identify potential artificial signals. A notable example is the SETI at Home project, which utilizes the processing power of millions of personal computers worldwide to analyze data collected by radio telescopes. This distributed computing approach demonstrates the scale of the challenge and the need for global collaboration in the search for extraterrestrial signals. Despite the challenges, radio astronomy remains a crucial tool in SETI, offering the possibility of detecting radio signals that could indicate the presence of technologically advanced civilizations in other corners of the galaxy. The search is patient, but the reward, the discovery that we are not alone, would be immeasurable. While radio astronomy searches for faint and diffuse signals in the radio spectrum, the optical search explores the possibility of detecting more directed and powerful signals, such as laser pulses. Imagine a technologically advanced civilization intentionally transmitting light signals to announce its presence. This is the premise behind the optical search, which uses powerful telescopes to look for anomalous laser pulses or other optical signals coming from distant stars. Unlike radio signals, which are relatively difficult to direct, optical signals can be focused on a specific target, increasing the chance of detection. However, the optical search faces its own challenges. Detecting extremely weak optical signals requires highly sensitive instruments and sophisticated data processing techniques to distinguish between artificial signals and natural light sources. The Earth's atmosphere can also interfere with observation, distorting signals and making detection difficult. Despite these difficulties, the optical search represents a complementary approach to radio astronomy, expanding the spectrum of possibilities in the search for signals of extraterrestrial technology. Optical search projects are under development, using ground-based and space-based telescopes to monitor nearby stars for laser pulses or other optical anomalies that could reveal the presence of a technologically advanced civilization willing to communicate with us through light. Beyond the search for directed signals, SETI also explores the possibility of detecting the presence of extraterrestrial civilizations through the search for megastructures, artificial structures on a cosmic scale, built by highly advanced civilizations. The most famous of these hypothetical megastructures is the Dyson sphere, a concept proposed by physicist Freeman Dyson, which describes a hypothetical structure built around a star to capture all its energy. A Dyson sphere, if it existed, would be detectable through its unique thermal signature, as it would block a large portion of the star's radiation, emitting heat in infrared wavelengths. Other hypothetical megastructures include O'Neill's cylinders, giant cylindrical structures that could house large populations, and dark matter rings, structures that could be built to manipulate gravity and create portals for interstellar travel. The search for megastructures is a considerable challenge, requiring the analysis of large amounts of astronomical data, as well as the development of theoretical models to predict the appearance and characteristics of these structures. However, the discovery of a megastructure would be overwhelming evidence of the existence of an extraterrestrial civilization technologically far more advanced than our own. The search for megastructures is not merely scientific speculation. It is an exploration of the technological possibilities that an advanced civilization could achieve, and a reminder of the vast timescales and spaces involved in the search for extraterrestrial life. The detection of such structures would be undeniable proof of the existence of other civilizations and a landmark in human history. Despite decades of searching, we still lack conclusive evidence of intelligent extraterrestrial life. This fact, seemingly contradictory to the vastness of the universe and the statistical probability of the existence of other civilizations, is known as the Fermi paradox. Several hypotheses attempt to explain this apparent contradiction. One is the Great Filter hypothesis, which suggests that there is a critical stage in the evolution of a civilization that prevents most of them from reaching a technologically advanced level sufficient to be detected. This critical stage could be something that has already occurred in Earth's history, preventing other civilizations from reaching our level of development, or something that is yet to come, preventing us from reaching a technological level capable of interstellar travel and contact with other civilizations. The Great Filter forces us to reflect on our own vulnerability and the fragility of life, and the importance of preserving our planet and our civilization. The absence of contact, so far, does not necessarily mean we are alone, but it invites us to a profound reflection on the challenges and probabilities involved in the search for extraterrestrial life and the implications of an eventual discovery. The answer to the Fermi paradox may be in the near future, or it may remain a mystery for future generations. The search for extraterrestrial life is constantly evolving, driven by technological advancements and new ideas. The future of SETI promises to be even more exciting and ambitious. With the development of increasingly powerful telescopes, such as the extremely large telescope belt and the square-kilometer array sky, We will be able to observe the universe with unprecedented resolution and sensitivity, significantly increasing our chances of detecting faint and distant signals. New data processing techniques and artificial intelligence will also play a crucial role in analyzing large amounts of information collected by telescopes, allowing the identification of patterns and anomalies that might go unnoticed by human analysis. Furthermore, new approaches are being explored, such as the search for biosignatures on exoplanets, signs of biological life on planets outside our solar system, and the search for technological signatures in other star systems beyond our galaxy. International collaboration and public participation will continue to be fundamental to the success of SETI, bringing together the best minds and resources in the world to meet this monumental challenge. The future of SETI is promising, with the promise of new discoveries and a deepening of our understanding of our place in the universe. The search continues, and the possibility of finding evidence of life beyond Earth is more real than ever. The quest for signals of extraterrestrial technology is one of the most grand and inspiring endeavors of modern science. Despite the challenges and the apparent lack of conclusive evidence so far, the search continues, driven by inherent human curiosity and the profound need to understand our place in the cosmos. Technologies are evolving, methodologies are improving, and global collaboration is intensifying. The answer to the fundamental question, are we alone? May be closer than we imagine, or it may remain a mystery for generations. But the search itself, the relentless exploration of the frontiers of knowledge, is a valuable journey that enriches and inspires us to continue looking to the stars with hope and wonder. The future of SETI is promising, and the search continues. Thanks for watching. Subscribe the channel and like this video to always receive more contents like this. I suggest you to watch our last video. It was amazing. See you later.